Today, we're solving one of the biggest mysteries in meteorology, in my opinion. We're going to be looking at the 186 mile per hour wind gust that occurred at Blue Hill Observatory on September 21st, 1938, in the Great New England Hurricane. So, this was at the time the world record highest hurricane wind speed ever measured. And today, it actually is still the highest hurricane wind speed ever measured in the United States. So, to say that this record stands in New England, not Florida, Gulf Coast, Texas, is it's crazy. How is the hurricane world record here? We're gonna look at how this wind gust actually happened. I have some great historical documentation from Blue Hill Observatory. We're going to be taking a deep dive at what they actually saw on this day, and we're going to be learning about the highest hurricane wind gust ever in the United States. Let's dive in. I am going to kind of give an overview of going into the hurricane a day or two leading up. So if you just want to know what it looked like when that world record wind gust happened, then skip to the middle point or second half of the video. But I think it's important here to paint the picture and really give the context. So on September 18th, really the important thing here is that they noticed that there is ridging offshore, which is preventing the hurricane from recurving. And then the next day, they do make mention of the cold polar air mass, which essentially is just a significant trough that was over the southeastern US. And this was a second big player in the field, which allowed the hurricane to almost get scooped up and pulled northwest slash due north. And this was a pretty impressive forecast to kind of note all this stuff and put it together. So first off, very, very interesting that this far out, they knew all the stuff. And getting to September 20th, so I'll start reading a bit more detail here. The wearing away of the modified polar air that kept the tropical air from the surface permitted a break in the dense low clouds, revealing this is altocumulus. Again, I'll skip over this a little bit, but I think the important thing here is they were actually able to measure the speed and the direction that the clouds are moving at Blue Hill. And then kind of going big picture here, suggestive of the time of movement of the hurricane northward from its recurve position east of Florida. A simple computation of how soon it might arrive was not attempted, partly because there was no indication that the speeds or direction observed here would necessarily be the same farther to the south. But on the basis of the usual hurricane speeds coming up the coast, it was guessed that the storm would reach here on Thursday the 22nd. So a forward speed of 30 miles per hour would get it here on the 22nd, which is probably pretty average for an East Coast hurricane. But of course, as you may have heard, this hurricane moved at 60 miles per hour, which is about as fast as ever has been documented. So it got there a day earlier because there was just an incredible acceleration. While the timing was wrong, the hypothesis was clear. The hurricane would get here to the 22nd. And if you've watched other YouTube videos or even just looked on the internet, historic accounts, reanalysis of this hurricane, it is commonly said that there was no warning. It's even been called the hurricane that struck without warning. And while the general public seemingly had no forecast, and probably some at the time forecasters did not say anything about this, internally at Blue Hill, they were expecting some sort of hurricane. Now, getting to the day of the action on September 21st. So, a few things I want to point out here that I think are particularly interesting, at least during the morning hours. We have breaks in the clouds. These are really detailed. They talk about the direction the clouds are moving at, the height. So this is a bank of clouds, which appears it came in from the south or the southeast, as you can see here. Stratocumulus, SC, dense bank low, became visible about 1:20, and shortly after the wind increased and the low clouds closed in and the hurricane was on. These cloud observations and a forecast were telephoned to the Boston office of the Weather Bureau, so obviously the modern day National Weather Service Boston, at 1:50 p.m. as follows. So these were actually, looks like the direction the clouds are moving at, which we actually do southerly winds aloft and east-southeasterly winds at 0.6 kilometers, and these were the speeds they were estimated at. So you could literally draw the hodograph on this day if you wanted to. So obviously there was evident vertical wind shear, as you'd expect, directional wind shear. But this is interesting. At 0.6 kilometers, so that's, under a mile, that's close to the 925 millibar layer, I think. Your wind was about, at least estimated, at 56 miles per hour. So obviously you already had somewhat of a low-level jet. I feel like this number should be higher, but it at least kind of makes sense. So we actually get a forecast here. These cloud observations indicate that the whole depth of the atmosphere up to at least 10 kilometers is moving from a little east of south, and therefore the storm south of New England must move inland. So yeah, this is literally saying that the hurricane would be hooking a little bit northwest / it wouldn't be curving out to sea. So spot on. Since the airways broadcasts show very low pressure at Lakehurst and Mitchell Field, the center will probably move northward or a little west of north through western New England or possibly eastern New York and at high velocity. Which this just hits the nail on the head. That's exactly what happened. I wouldn't change anything about that. There should be intense rainfall, but not for too long. Again, correct. It didn't even really rain at all, as you'll see. But yeah, to even say it wouldn't be prolonged rain in a hurricane, which is unusual, is pretty crazy. The center should be well past and the weather clearing with wind shifted to southwest by midnight. At this time, I telephoned Harvard University to prepare for southeast changing to south gale of at least 60 miles per hour from the late afternoon and early evening with heavy rain, which last, however, did not come, most fortunately. A few others were given the same warning. Southeast changing to southerly winds, of course. Now, obviously, the magnitude of wind was massively underdone. However, can you really be surprised when a hurricane like this really hadn't been documented, at least like this century? So that's still a pretty bold forecast, and considering they didn't have radar satellite observations, I think this is a pretty good forecast. The following is quoted from the Observatory Journal. Wind increased rapidly after 2 p.m. with approach of hurricane. At 3:01 p.m., blades on windmill of anemoseismograph blew off after recording 37.2 meters per second. So that's a hurricane force gust. I think 80, 90 miles per hour. I'll put it on the screen when it is officially. 3:14 p.m., lights failed. 3:30 p.m., apple tree in yard split. Also 3:30. Spray being lifted off surface of Ponkapoag, a pond 1.5 miles away and a little under a half mile across, possibly 30 feet in the air. I will interject here really quick and say that Ponkapoag Pond is actually 400 feet lower in elevation than Blue Hill. So it was literally, the spray was lifted up through the hill, fighting gravity. 3:40 p.m., covers of coal bin carried off and split. 5:21 p.m., one complete revolution of spindle from 3-cup anemometer timed in 35 seconds, accurate to 3 to 5 seconds. So again, it's important to say that a lot of how they measured wind back in the day, and especially at Blue Hill, was actually rates of how much a anemometer would spin in rotation-wise in a certain amount of seconds, pretty much. 5:24 p.m., phone tried and out. 5:20 p.m., odor of bruised oak and cherry leaves very noticeable outside. And again, I just want to say how incredible this is. It literally smelled of tree because of how many trees were getting destroyed at this point. About half of trees on south side loosened and partially uprooted, many totally blown out of ground or snapped across trunk, leaves frayed and whipped off all trees, most of which have bark worn off of minor branches and large branches snapped off. 5:50 p.m., standard barometer, some measurements we have here. Skip over that. Large window including frame and south side of lower bedroom blown in. 6 p.m., bright spots in cloud deck and east. Now, this was in the eye. I know this could be confusing, but the eye went up through the Connecticut River Valley. It went up in western New England. So this was not related to that. However, I think it's important here that we have bright spots, and you'll see the 186 mile per hour wind gust occurred very, very close to 6 p.m. So you actually had, I don't want to say the sun was out, but you had probably some modest clearing in the sky during the world record wind gust. Here we have some eye observations of literally what direction the wind was. It appears that whatever the air vane that they had to measure the wind direction literally broke. So obviously they had, yeah, it says here, I can't read. So they eyeballed this, but here's what's interesting. 7:15, stars visible from base, and we actually, by 1 a.m., see that the stars were very bright with no clouds. So it cleared out pretty quickly during the second half of the, quote, hurricane. The wind on Blue Hill reached 60 miles per hour shortly after 3 p.m., and it remained continuously above that velocity from 3:35 to 6:45 p.m. From 4 to 5, the wind averaged 83 miles per hour. And again, this is so impressive. I want to say this is not any sort of 5-minute sustained wind. This is averaging all the wind for a full hour, which I don't know if 83 sounds like a lot, but that is, you're averaging above hurricane force for an hour. That's incredible. 50 miles of wind went by in only a little more than half an hour at 94 miles per hour. So again, we see a rate that they use here. This is how they measured wind at Blue Hill back in the day. Is literally your anemometer spun enough times for 50 miles of movement of wind in half an hour. In 3 5-minute periods at 5:05, 5:20, and 6:12, the wind reached 111 miles per hour. So this would be 3 instances of sustained Category 3 wind. The excess over the Weather Bureau's 88 miles per hour, so some sort of small measuring issue there. Don't really care too much. Though the wind kept up at a high velocity, it was punctuated by great gusts, which would last for a few seconds to a minute and break a world record. The most sensitive recorder on Blue Hill, a French windmill anemometer, started to disintegrate when registering a 5-minute velocity of 80 miles. The gust broke it being well over 100, so sustained 100. We have to use a cruder recorder from the heavier 3-cup anemometer for such details as to the force of the gusts as can be obtained. From this record, it appears that there was a passage of 7 miles of wind in 2.5 minutes at 5:59 p.m. and one of 4 miles in a little over a minute at 6:15. With due allowances for instrumental errors, it appears that these gusts were approximately 173 and 186 miles per hour. So you now have everything you need to know. So we first had a supposed gust of 173 miles per hour at 5:59 p.m. Again, that is literally when there were breaks in the clouds. When there was sunlight visible, this gust happened. And then 16 minutes later, supposedly the big one that, this 173 also would have at the time been a world record, but the 186 which still stands today.
This is where it happened. This is Blue Hill Observatory in the present day. This is the location of the world record U.S. hurricane wind gust, and you can go here whenever you want. This is the rooftop of Blue Hill Observatory. This is where the anemometer was sitting that recorded a sustained 121 mile per hour wind gust. So this is where the record stands. And this is a recent windstorm with a 90 mile per hour wind gust and a 60 mile per hour sustained wind. So if you're wondering what the 1938 hurricane looked like, it was literally double this.
The CU at 4 were moving at a speed which, if their height was 500 meters above the hill, would be 45 to 61 miles per hour, more likely at this height, which would give. So this is estimating the low-level jet. This honestly seems really low if you were sustained 110 to 120 miles per hour. But, obviously it does. You have to just think about, in any case, whatever the number is, you were looking at clouds that were literally moving at time-lapse speed. I mean, think about what the low-level jet looked like just looking up at this point. So continuing on with this thought, they literally were holding their fingers up to look at the motion of the clouds and estimate the speed of that low-level jet and the winds aloft, which obviously, again, it's underdone, but it's a pretty good estimate. Therefore, the 93 miles per hour may be taken as a likely minimum figure, which, again, I definitely agree it's probably a little low, but these values from the cloud motions are fairly in accordance with the velocities observed on the summit of Blue Hill, with the wind speed lost by friction with the ground was made up by the concentration of movement by the summit of the hill. So I think this is literally saying that while friction means that the wind speed should be less, that the summit of the hill did actually speed up the wind as it was forced to rise. Through a break in the lower clouds at 5:40 p.m., when the sun shone on the CU tops, a layer of cirrus and cumulus, or altocumulus, was visible moving from approximately south, maybe a little east of south, at a speed of that. By comparison with the observations made early in the afternoon, it seems that this is probably the lower altocumulus level, though it gave the appearance of being a fairly large cirrus and cumulus rather than altocumulus. These cloud types are important, as you will see. I mean, you could literally draw what this looked like, but it actually tells us a lot about where there was or wasn't moisture and instability in the atmosphere, which will be very important a bit later on. Precipitation fell at Blue Hill from 1:50 to 4:40 and from 6 to 7:55 p.m. The rain essentially being showery, though continuous between showers. The visibility was fairly good before the rain set in, and the fronts of some of the advanced showers seemed to be very sharp. So I think it's important here to kind of talk about. I'm going to interject a little bit and talk about some of the meteorology behind what was going on, what this really means, and how a 186 mile per hour wind gust actually was possible, because I think you really can extract all of it from these next few paragraphs. This was not a steady, soaking stratiform rain event with a big rain shield that you would expect during a hurricane. These were low top tropical showers. The amount of precipitation to 7:10 p.m. was 12 hundredths of an inch of rain. This is incredibly low for a hurricane. This actually might be one of the top 5 findings from this whole examination we're doing. The lack of appreciable precipitation indicates a considerable stability above the low turbulent layer. The tops of the CU clouds, when seen at 540, were apparently not more than half as high as the base, or not more than 1,500 meters above sea level. The air above seemed to be considerably drier, since there were no clouds higher up until the altocumulus layer was reached. These clouds were not particularly thick. So, got a few things to unpack here. So, these convective showers, these tropical showers we talked about, were very, very low topped. So, we have a clear inversion that was in place probably between the 700 to 850 millibar layer, which stunted vertical development. Why did we have a inversion? This was a warm core system. This was a hurricane. So you had a lot of warmer air aloft, although at the ground level, I think that we actually had steep low-level lapse rates with an inversion aloft, and that is because there was influence from continental dry air, which we will talk about in the next paragraph. But with that inversion, that stunted vertical development, and that probably prevented what could have actually been more convective. But I think that's only part of the, or even less than half of the situation. I think the majority of it actually is. There was very dry air aloft on this day. And that's why they literally said above this, the boundary layer where the LCL is, where you get these convective clouds higher up, it was clear. And, maybe some upper level clouds with ultracumulus, but it was clear. You didn't have your, thick stratus or anything. So it was obviously there was a wedge of dry air aloft. It seems that the very strong pressure gradient near the ground, which caused the wind at hurricane velocity, was appreciably greater than the pressure gradient not far aloft, and the severe mechanical stirring drove the air to such a height that the upper portion of the surface layer was probably colder than the air immediately aloft, thereby preventing any considerable vertical development of convection within the CU cloud layer. So, yeah, this is just kind of summarizing what I said, which is there was an inversion and that, stunted convective development. However, it's also amazing that they actually figured this out in the 1930s. The apparent dryness of the upper air, and indeed the moderately low dew point 60 of the lower air, strongly suggests that the speed of the circulation about the hurricane center was sufficient to have brought air from over the continent around the south and southeast margin of the circular whirl and up into New England after only a rather brief stay over the sea. So, a lot to unpack here, but this really kind of drives home the point that I'm talking about, that there obviously was a lot of dry air, probably in the mid-levels, but also it was maybe not dry in the low levels. A dew point of 60 isn't truly dry, but it was abnormally dry for a hurricane, and there was a ingestion of significantly drier air, and this served to sharply steepen low-level lapse rates, and this gave us something that we call mixing. Typically in hurricanes and high wind events, you can have a little bit of an inversion with warmer air immediately, and I mean feet aloft, literal feet aloft, it can be warmer, and that prevents the wind from mixing down. However, in this case, I believe that the lapse rates were very well mixed, and this actually allowed very intense winds to freely mix down to the surface. So while this was a Category 3 hurricane with a very intense wind field, it also was a perfect storm in the fact that it allowed almost all of the wind to perfectly mix down to the ground. So Does this answer some of the question about how the 186 mile per hour wind gust occurred? I really think it does. It was incredible mixing with a pretty dry ambient environment. And the final thing I do want to add here is it's actually possible that we even had something that you would almost see in the Rocky Mountains. You talk about a downslope windstorm. The model SQT for that is you have an inversion at mountaintop around 850 or 700 millibars, and that actually prevents the wind from going upwards in the atmosphere. It funnels the wind and accelerates it downward to the ground, and that's how you get downslope windstorms in Colorado. And it's actually possible here that we had that inversion around 850 millibars, which literally funneled even more wind closer to the ground. And given that you probably had some sort of dry conveyor belt or possibly even a sting jet developing with that descending dry air, this literally forced this insane wind against its will to descend into New England. So I think that as much as this hurricane had an insane wind field to begin with, there were obviously some perfect factors that came together to allow this 186 mile per hour wind gust to occur. So does it make more sense now? It absolutely does, but it's amazing how much came together, and this is not what I would have thought at all it looked like before reading this. So not too much to say here, but we will read this paragraph. If the body of the air in the hurricane was thus appreciably drier than the normal air that feeds into a hurricane in the tropics, it would seem that the intensity of the storm should have been appreciably diminishing on its northward movement. This may have been the case without reduction in the wind velocity east of the center, since the increase in its northward rate of progression would increase the wind velocity about as rapidly as the decrease in the general rotary rate of the storm would decrease it. So here we get really two additional factors that also suggest how a 186 mile per hour wind gust from a hurricane in New England actually was possible. In addition to everything else I said about kind of the thermodynamics and what the SQT would have looked like on this day, literally this hurricane was moving at a record 60 mile per hour forward speed, and it was undergoing strong extratropical transition with that dry continental air coming in. So literally, this is well known, obviously, but if you have a hurricane moving at 60 miles per hour, obviously that is going to make it more favorable for very intense wind on the eastern flank. So was this the only factor? I think that there's way more to the story than the speed for this 186 mile per hour wind gust, but I do think that it did play a role. Though the destruction was very great over a considerable area, so this is pretty much saying that there actually were some areas that didn't get hit too hard, but there were belts or spots where the wind had a free sweep off the water surface or across open fields. Topographical configuration, big words for the 1930s, tended to concentrate the blast. So it appears that the damage came in bursts, which, given it seems like that there was turbulent, tremendous mixing in the boundary layer, that kind of makes sense. So here we just kind of compare to some other storms. We'll skip over that because there's so much other stuff to talk about today. But here's some other historic storms. You want to look them up. Really, nothing comes close to 1938, but these were big storms too. All right, we are now getting to something very exciting. We have archived weather observations from this day, hourly observations from Blue Hill. We have station pressure, sea level pressure, we have some wind data, temperature and moisture data, and even precipitation. So kind of going through everything here, starting with the pressure. Nothing too exciting, obviously. It fell a lot. We got down to a sea level pressure of just about 29 inches of mercury. So there's that. Wind speed, obviously, southeasterly. The peak of it, we were from the due south and eventually southwesterly as the hurricane was pulling away. Nothing really should surprise anyone there. So 2 wind velocities. Neither one of these is a gust. So we have the velocity hour. So this is literally the average velocity for a whole hour. We were averaging, looks like, pretty much over 30 miles per hour for an hour the entire day. And we averaged up to 80 miles per hour at 6 p.m., which I already talked about. Is just incredible. So 5-minute, this is your sustained wind here, 5-minute wind. So we were sustained tropical storm force, it looks like, between 1 and 2 p.m., and we were tropical storm force sustained for the rest of the evening. Hurricane force sustained from 4 p.m. to about 8 p.m., And within that, we have 2 hours here of, you know, approaching sustained category 3 wind. 7 p.m., we are well into the category 3 hurricane sustained wind zone. So again, 121 mile per hour sustained wind. That's just unfathomable. And that honestly might be almost as impressive as the 186 mile per hour gust. Getting to temperature data, it started mild on this day. We started off in the lower 70s, and we actually get to the mid 70s. And I'll show you on the next page. But our high temperature, I believe, is registered as 76 or 77 degrees. So it was mild. It wasn't warm, but obviously it was mild. Now, here's the interesting part is when the wind really gets going, our temp's initially near 70, but once we get to the highest wind gust of the day, 7 p.m., our wind gust actually falls from 71 to 61 degrees in a 2-hour period as we're getting that 186 mile per hour wind gust. So, walking in to this event, hearing about this event online, I'm sure you were probably thinking, as I was thinking, the guy with the meteorology degree, I was thinking, okay, surely we're in like the low to mid 70s, your dew point's in the 70s, it's sideways rain. No, your temperature was in the low 60s when this gust happened. So I don't want to say it was like a nor'easter, but this was a borderline cold wind. This was not a mild tropical wind. So very different from other New England hurricanes, notably cooler. And that is all to do with that ingestion of the continental tropical air that allowed for really good mixing with probably even colder air aloft. Our temperature eventually fell into the upper 50s while the hurricane literally was still happening. Dew point generally was in the upper 60s during the first part of the day. Okay, that's normal. That's tropical. But look at the drop in the dew point, going from 68 at 3 p.m. to the 50s in the evening. So, once again, continental air came in here. It dried out pretty quickly. So your world record wind gust, your dew point, it appears, it was in the upper 50s. Again, not what I was expecting. Some instances of precipitation, it looks pretty light. Again, only 0.12 of an inch of rain total. And it did happen, I guess, when the wind was hurricane force. So maybe a brief tropical downpour was able to maybe mix a little bit of wind to the ground, but it really looks like that wasn't the mechanism. In fact, when the 186 gust happened, it didn't even rain. So did the ground even get wet on this day? I mean, barely. Some more observations here, both on the September 20th and 21st. These are more to do with cloud type. I will just kind of breeze over this because I don't think it's anywhere near as interesting as what we've looked at already. And that's why it is a little bit in the later part of the video. But again, pause and look in detail if you want. This is an interesting point at the bottom here. Damage due to storm, about $50 per building in the nearby vicinity, which today's money, this is thousands. 850 trees down along parkways in the reservation. So that's literally like a 2 or 3 mile road that you would take to get up the hill, which you can still take today. Over 1 million trees down in reservation as estimated by officer in charge of Blue Hills Reservation. 7,000 acres. So 1 million trees down in the entire reservation. I think the thing here that's interesting is, of course, we have the 186 mile per hour wind gust, but the context is this was a derived or estimated wind gust. And we have, Boston, Providence, Block Island, these are in the 80s to 90s for wind gusts, but all of these are sustained winds. These are not gusts. So these are some pencil observations from the days leading up to. Here's the date. Again, if you want to look in detail, pause the video, but the only thing I really want to report here is if we actually look on the 20th, which is the day before, what's that? We actually have a thunderstorm, or a few instances of thunderstorms reported. One from, it looks like, roughly noon to 1 p.m., or maybe noon to 2 p.m. And then another one roughly in the evening hours. I think that's 5 to 6:30, and then another one from 9:30 to 1:30 a.m. So there was excessive thunder the day before, and we actually got about 4 inches of rain just from the total rain the day before. Obviously, the hurricane gave very little rain, but it's interesting that you had that stationary front overhead the day before, and that's what gave a lot of the flooding in western New England with the predecessor rain event. This was an obvious predecessor rain event, as that tropical moisture was funneled up ahead of the hurricane, but that's a lot of thunder for the day before, especially for September. Here is also some more pencil observations. Again, just look on the left side and see what date it is. So here's the 21st. I'm interested in the high and low temps here and stuff like that, even the day or two before. So it appears that our high temp on the 20th reached 75 degrees with the low around 68. So very, very humid. We actually had temps in the 50s for a few days earlier. We were on the cold side of that stationary front with probably northeast wind. It was still raining a lot, but it was a cold, damp day. And then we quickly jump up towards the 70s with winds turning southerly. And then hurricane day itself, our high temperature is 77 degrees with a low of 59. So that is a split if you're wondering. More detailed observations, it looks like we kind of spend the day in the upper 60s, lower 70s. On the 20th and then the 21st, we're up 76 degrees at 1 p.m. Then, of course, we fell into the 60s in the evening. So it started mild, but the hurricane was not dominated by mild air at all. And I will let you look at this if you would like to, but this is just simply some more observations. Looks like temperature and visibility, cloud type potentially, remarks on the right side. And that is all I have.